All right, let's keep going with a few more. So this problem has a square root in it. So remember, square roots tell us we have to check for extraneous solutions. So we're looking for extraneous solutions. And I'm just putting off to the side. We're not going to do that till the end. But I'm going to make sure I remember to do it from there. So when we start solving this, remember we want to get the radical, in this case the square root by itself, which it is. So the next thing I need to do is isolate it, or not isolate, eliminate it, meaning get rid of it. So that square and square root cancel each other out. So I have 3x plus 40 equals x squared. Now if you see an equation like this where there's an x squared term and there's a term with just an x, that's a huge indication that we need to get it equal to 0. So I'm going to subtract everything onto one side, or move everything to one side. I personally like to keep the x squared term positive. It makes factoring easier. So we have 0 equals x squared minus 3x minus 40. Okay, at this point we're going to go ahead and factor. So I'm looking for factors of negative 40 that add up to negative 3. Since it's negative 40, one's going to be positive, one's going to be negative. So it's going to be negative 8 and positive 5. So I'll have x minus 8 and x plus 5. So I'd have two solutions, x equals, because you're finding the zeros, right? So x equals positive 8. And x equals negative 5. So let's go ahead and check for extraneous solutions. So when it comes to extraneous, you're going back to the original problem, so back here before I squared anything and whatnot. So I am going to check positive 8 first, because we have to check each one of them. So we've got the square root of 3 times 8 plus 40. I want to see, is that actually equal to 8? That's the big question. So 3 times 8 is 24, plus 40 is 64. Well, is the square root of 64 8? Yes, it is. So that is good to go. So we know 8's good. So let's try negative 5 now. So I'm trying to see 3 times negative 5 plus 40. Does that actually equal negative 5? 3 times negative 5 is negative 15 plus 40 is 25. Now this might seem weird because usually when we see square roots we always say there's a positive and negative. If the square root was already there though, it's already implied it's positive. So our answer should be positive 5. But we said it was supposed to equal negative 5, which is false, which means negative 5 is actually extraneous. All right, that was so fun. I know you enjoyed that, so let's do another one. Okay, same idea. So we've already got a square root. I'm going to go ahead and square both sides. So I have 2x. When I say it's a square root, I should back up. Because there is a square root and it was already isolated, we can go ahead and square both sides. And also because there's a square root, we will have to check our answer at the end. So I'm just going to, for extraneous solutions. Okay, x minus 4 squared is the same thing as x minus 4 times x minus 4. So make sure you break it up and then distribute. So I'm going to keep the 2x. So x times x is x squared. X times negative 4 is negative 4x. This is negative 4 times x is negative 4x, and then negative 4 times negative 4 is a positive 16. Then I'm going to go ahead and combine like terms. So you have x squared minus 8x plus 16. Okay, at this point, I'm going to go ahead once again, since there's the x squared and the x term, we want to get it all equal to 0 because we're going to end up factoring to solve. So if 0 equals x squared minus 10x plus 16. So for this problem, we're looking for factors of 16 that add up to negative 10. Since it's a positive 16, they're both going to be negative. So we have negative 2 and negative 8. Or since it's positive 16, the signs are the same. And they both have to be negative because it's negative 10. Sorry, I said that a little wrong. So we've got x minus 2, x minus 8, which means our answer would be x equals 2 and then x equals 8, because you're finding those zeros. Okay, let's go ahead and check. And once again, when you check, you always check both of them. So let's try x equals 2. So the square root of 2 times 2, is that going to equal 2 minus 4? Square root of 2 times 2 is 4. 2 minus 4 is negative 2. Square root of 4 is positive 2. And positive 2 does not equal negative 2, so I'm going to get rid of that one. So then I'll try x equals 8. So square root of 2 times 8 equals 8 minus 4. Let's see if that's true. 2 times 8 is 16. 8 minus 4 is 4. And the square root of 16 is 4. And 4 does, in fact, equal 4. Fun fact. And there you go. All right, let's do one more of these fun ones before we stop, and I'll do another video for the other last ones. But so we've got 2 square roots there on different sides. That will happen sometimes. So easy, because you can just square both sides and both square roots are gone. So in this case, 2x plus 3 is going to equal x plus 2. So I'll go ahead and subtract x from both sides. So x plus 3 equals 2. Then I'll subtract 3. Notice I didn't set it all equal to 0. You certainly can, but there's no need to because there's no x squared term. So I can just get the x's alone, the constants alone, and call it good. Okay, so we got x equals negative 1. Now, you still, since there was a square root in the original, need to check for extraneous solutions. So I'm just going to double check. Does 2 times negative 1 plus 3 equal the square root of negative 1 plus 2? That's the question of the day. So 2 times negative 1 is negative 2, plus 3 is a positive 1. Negative 1 plus 2 is a positive 1, and square root of 1 in both cases is 1, so it works. So just as a little refresher before I do my last video, the only time you don't have to check for extraneous solutions is if the original problem had a cube root or something like that. In other words, the only time you have to is if you see the square root. That's when you will check for extraneous solutions.